Hello guys, am I audible? Before we start, I always say you hit like, you know. So can I see some likes? Yeah. Okay, perfect. Am I audible? Good evening. Good evening, everyone. Okay. So the first thing first, I hope everybody has joined the community session because many people were asking for the materials. So if you go to this particular thing, you can see if you play the yesterday's video, you will be able to find out the materials over here. Okay. So it has already been included. So please make sure that you enroll for this free community session. Okay. And make yourself ready for the like every time whenever like live day 2, right? So today also video is already being streamed over here so that you'll also be able to get the notification. Okay. So please make sure that you keep everything ready before we start the session. So everybody is enrolled in the community session, guys? Yes, everybody is enrolled in the community session, right? So just give me a confirmation. I will just remove this now and probably we can start today's topic. So yesterday, if you remember, we have discussed all the basic things. Today, we will be moving from basics to intermediate, right? So we are basically going to move from basics to intermediate stats specifically for data science. Okay. So this is what we are going to discuss, and there are so many topics that I am probably going to cover. Today we are basically going to cover uh, measure of central tendency, measure of central tendency, measure of dispersions, measure of dispersion. Then probably we'll start with Gaussian distribution. Then fourth, we are going to understand Z-score. Then we are going to understand standard normal distribution, and there are some more topics that we really need to cover. Okay. Can you make the background a different color? So many people have problem with the background. Keep on hitting like, guys. I need to see many likes. That is how my energy will generate. So is the background a problem, guys? Is the background a problem? Just let me know. Then probably I have to fix up the background also then. No, right? So I think many people are saying no. So I'm just going to keep the same thing, that is background blur. I will make sure that my photo looks smaller and most of my body part is basically shown to you. I know you love my body parts, right? So I'm just going to make it small so that I will be able to write more. Okay. 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 So what I see, the volume is full high. So probably we can start the session because I can also see from my YouTube video the voice is louder. Okay. Okay. Now let's go ahead and let's start today's session. What all things we have discussed yesterday, guys? What all things we have discussed yesterday? Who have attended the yesterday's session? You saw that we discussed many things related to statistics, right? Yeah. So please just name out the topics that what all things we have actually seen for the yesterday's session. So the first topic that probably we are going to discuss is something called as arithmetic mean for population and sample. Yeah. So till then, you just write down the topics, whatever we have learned yesterday. I can see a lot of things people are saying about different topics. Perfect. So I think everybody is with me, and you should not think that I'm teaching something new. And again, understand those who are directly come for learning advanced section, you can just skip it because I'm just going to start from basics. From tomorrow, more complex things are going to come. Okay. So please make sure that you have that thing in your mind. Okay. Okay, so let's start with the arithmetic mean for population and sample. Here, mean basically means over here, specifically, we are talking about average. Now, with population and with sample, we really need to understand the formulas of mean, and we will try to understand in this specific way. Population is basically given by capital N, sample is given by small n, which we have discussed in the last session. Okay. Now, coming to the first thing, whenever we are probably discussing about mean, you need to remember that we are trying to find out the average of a specific distribution. So let's say that my data set looks something like this: 3, 3, 4, 5, 5, 6. So if I really want to find out the mean of this population, okay, mean of this population, I can basically give by a symbol which is mu. Okay, this is mu. So I can basically write mu, and I'll say summation of I is equal to 1 to capital N x of I divided by n. Okay. So I hope everybody is very much familiar with this. Don't worry, because we are going to discuss many things. Okay. Now, what is this x of I? Let's consider that this is my random variable x. Okay. And probably I have so many different values inside my data set. 1 1 2 2 3 3 4 5 5 6. So if I really want to expand this thing, x of I, basically we are going to iterate through all these n elements. So I may write 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 6 divided by capital N. Over here, capital N is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 elements. Now, if I try to find out the average, please have somebody help me out. 4, 7, 8, 9, 12, 16, 17, 22, 28. 28 by 10, which is nothing but 2.8. Okay. So if I'm considering X as my random variable, which is the population data set, if I really want to find out the mean, which is denoted by mu, so here you will be able to see that I'm able to find out the average. Okay. So what is the sum that you have probably got, guys? 6 plus 5, 11, 11 plus 5, 16, 20, 23, 26, 28, 30, 31, 32. Oh, sorry. Then I made a mistake, right? So this is 32. 32 by 10. So it is 32 by 10, which is nothing but 3.2. Okay. So 3.2 is basically my average. Okay, 3.2 is basically my average. I'm extremely sorry. Maar mat dena yaar mere ko. I am a human being. I can make mistakes. Okay. Many things are going here in my mind. So it happens. Now, with respect to population, always remember how the symbol is basically given. We can write x bar, which is specified by sample mean. Here I'm going to write summation of I is equal to 1 to small n. And here I can basically write x of I divided by n. Obviously, we'll get the same answer because we are going to take the same data set. Okay. PDF is already updated, guys. You can see in the resource folder of that specific video. Okay. So this was the example with respect to arithmetic mean. Okay. Uh, Always understand that notation. The notation is quite important over here. The reason why I'm saying you notations over here in this way, because because in the real world industry, when you are working, when you're explaining someone as a data scientist, you really need to use this well-known notation. You can use your own notation, whatever you like, but think of a larger point of view. Here, you really need to make sure that whatever standards is being followed, we need to try to follow in that specific way. Okay. So this was the basic things with respect to mean. Mean is the part of central measure of tendency. So central measure of tendency, apart from mean, there are two more things. Okay. So let me just define what is central tendency. Okay. So central tendency, which we basically say central measure of tendency, there are three main things. One is mean, second one is median, and third one is mode, right? Now, if I really want to make you understand, because it is a very important interview question. If someone says you that what is central tendency, or so what is measure of central tendency, right? You can just say that it refers to the measure used to determine the center of the distribution of the data. So that basically means whenever I have a data, right? If I really want to find out the center part of that particular distribution, I can use mean, median, mode. Why specifically we'll be using it, that all I'll be talking about, but I hope everybody got the definition till here, right? So everybody clear with this? No guys, sample mean we don't use n minus 1, okay? Everybody clear with this definition? It refers to the measure used to determine the center of the distribution of the data. Okay. So average and mean are one and the same, guys. Understand average, mean. Okay. We use the same formula that is basically used. Okay. So it actually refers to the measure. It refers to the measure used to determine the center of the distribution of the data. Okay. So so this was the part with respect to central tendency. Now let's go ahead and let's try to solve some problems, right? Obviously, I have given you a lot of examples with respect to mean, but now let's go ahead and try to understand median. And why do we specifically use median? So I'm going to take the same data set, whatever data set I have used over here, that is 1, 1, 2, 2, 3, 3, 4, 5, 5, 6. Okay. So 1, 1, 2, 2, 3, 3, 4, and what was the data? Then you had 5, 5, 6, right? So here I am basically going to take 5, 5, 6. So suppose if this is my data, obviously the mean we found out was nothing but 3.2. Now what if I tell you that in this distribution you add one more element like 100? So when you add 100, what will happen? Tell me. Then it will become 32. Then it will become 32 plus 100 divided by 11. I hope you understood from where 32 is basically coming up, right? Because 32, okay, 32 is basically from the sum of all the numbers that we have done taken previously, plus sorry, plus 100, which is a new element that is basically added, and we are just going to divide by 11. Okay, so once I do 132 by 11, what is 132 by 11? Let me open the calculator in front of you. So 132 by 11, 132 by 11 is nothing but 12, right? So here we are able to see that we are getting 12. Before, when 100 was not added, when this element was not added, at that time my mean was 3.2. But after adding 100, right, in that specific distribution, my mean became 12. Now here you can see that there is a huge movement of mean, right? Huge movement of mean, right? There is a huge difference with respect to this mean. And why it is basically added? Because of this number. We consider this number as outliers. Okay. So we consider this numbers as outliers. Outliers really have a adverse impact on the entire distribution. Okay. Adverse impact on the entire distribution. So that is the reason why we specifically use, why we should be very much careful with outliers. In data science also, in statistics also, we use different techniques to remove the outliers, which also I'll be discussing today in front of you when we are going to discuss about percentiles and all. Okay. So remember, outliers has a major impact because here you can see that the entire distribution of the central data is basically moving, right? And the difference is quite huge. So for this particular case, what we do, we can definitely use median. Okay. Now in median, if I take the same number like 1, 1, let's say that I am taking the number 1, 1, 2, 2, 3, 3, 4, 5, 5, 6, and then probably I have 100. Always understand in median, the first thing that you really need to do is sort the numbers. So first step is sort the numbers. So over here you can see that the numbers are already sorted, right? If your numbers is not sorted at that point of time, you will be able to see that you probably have to sort it. Right now by default I have made sure that the number is already sorted. Okay. So do you define distribution in statistical term? Distribution basically means that how your data looks. See, what is distribution? What is distribution? Okay, how do you see how your data is basically distributed? There are various ways. We use PDF, we use histograms, we use different techniques. So I will be coming in making you understand about different distributions. Still, I have not started that. Okay, but till here everybody is clear, guys. Till here everybody is clear. Yes or no? Just let me know. Okay. So I feel everybody is clear with respect to this, whatever things I'm actually discussing, right? So now let's go back to median. Okay. Now, first step is always sorting the numbers. I have sorted the numbers. After sorting the numbers, what I am actually going to do is that I am basically going to take the central element. Okay. Now, central element means which one? Suppose if I have odd number of elements, if the total count of the elements are odd number, okay. So over here, what is the count? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 is the count. In order to find out the central element, okay, we will probably find out the center one. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this will basically be my central element, right? This will be my central element because it is the middle element. Okay. Now in this particular case, I can definitely say that my mode is nothing but 3. Now understand, even though the outlier is added, see, outlier basically means what? Outlier is a number which is completely different from the entire distribution. Okay, completely different from the entire distribution. Over here you can see that 100 is a completely different from the entire distribution. Now what if, now your question may rise that, okay Krish, what if I have one more number like this? Let's say that I have one more number 112. Now in this particular case, you told to pick up the central element. Now in this case, which will be my central element? Now in this case, my total number of elements are 12, right? So in order to find out the central element, what I will do, I will take up the middle two elements. Okay, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the middle elements is basically present over here. Now here, I will take this middle element, which is my 3 and 4, and I will do the average of them. So 3 plus 4 divided by 2. What is 3 plus 4 divided by 2? It is nothing but 3.5. So in this particular case, I can say that my mode is 3.5, even though I had two different outliers. But yes, if I keep on increasing the number of outliers, then the distribution will become normal, right? Now understand one thing, why mode actually works in a better way. Before, because of this outlier, my mean was how much? 12. Even though after adding the outlier, my mean was 12, right? But now here you can see that even though I added two outliers, my mode, which is again a measure of central tendency, okay, there is hardly any difference, a very less difference. So that is the reason why we use median. Did I say mode? Oh, sorry. It is median. Oh, today I am little bit disturbed, I guess. Okay. My mistake, guys. Okay, median. Okay, median. Sorry, don't kill me now. Okay, so by mistake I wrote mode. It should not be, okay, median. Okay, so median, I hope everybody understood what exactly is median. We basically take the central elements. If the number of elements is even, then we probably take the central two elements, we try to find out the average and we try to calculate it, right? But understand one thing over here. What is the main purpose? Initially, when we did not add outlier and we tried to calculate the mean, at that time I got 3.2. Okay. When I tried to calculate by adding an outlier, my median was 12. Sorry, my mean was 12. When I try to do this with respect to median, even though I had added the outlier, it came as 3, right? And finally, you'll be able to see that when I probably used two outliers and then probably I got the median as 3.5. Now here you can basically see that there is less difference, right? Less difference when compared to this, right? So if I talk about median, it works well with outlier. It works well with outlier. Okay. So this is the proper statement that I want to consider. Okay. Yes, guys, I understood it is median, 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 median. I'm extremely sorry. Median. Okay. So today no Red Bull. Everybody took up yesterday. So now let's go ahead and try to understand about mode. Okay. So in the case of mode, the third topic. Okay. The third topic. Okay. फाइन फाइन नाउ डोंट मेक फन ऑफ मी यार कम ऑन एक गलती कर देता हूं तो दुनिया पूरी जूता मारती है हैं आई थिंक यू हैव हर्ड अबाउट दैट कहावत ओके okay so median we have basically used. Now let's go towards mode. Okay, now suppose if I have a specific data set like this: 1 2 3 4 5 6 6 6 7 8. Now even though I have some outliers like 100 200, now in this particular case what should be our mode, which is again taken as a measure of central tendency. Okay, okay. Now over here in this particular case, in mode we find out the most frequent element. Most frequent element. Okay, now in the most frequent element we just try to count and we try to see that which element is having the maximum number of elements. So over here you can see 6 is basically having 3, the count is 3. If you see 2, the count is 2, right? So in this particular case my mode should definitely be 6. My mode should be definitely 6, which is again the measure of central tendency. Okay, now see guys, now in this particular case there is one disadvantage. Okay, even though suppose let's consider that I have many outliers like this 100 right, or one more 100, let's consider. Now in this particular case, since we find out the most frequent element, we try to take this as an outlier, right? So usually in most of the outliers that we specifically use, we basically use median. Now where specifically mode is used, let's consider one data set. Okay, let's say that I have a data set which is called as gender. Okay, salary. Let's consider I have this. In gender you will probably find out male female male female. Okay, some different values may be there. Okay, or let me just change this data set and make it in a simpler way. Why specifically we use mode? In mode also we use it in both integer and categorical variables, but it works well with categorical variables. Let's say that this is a type of flower. Okay, type of flower, and this is petal length. Okay, and petal width. Okay, now over here you'll be able to see different flowers like rose, lily, okay, sunflower, and you have some flowers. Let's consider that you have some missing data over here. Okay, you have some missing data. Okay, and based on this missing data, now this particular data set has come to me, and let's say consider that I've seen in this particular data there are around 10% missing data. Now, what do you think? In order to handle this missing values, what type of things we can definitely use from mean median mode. What technique can I use? Don't you think I can definitely use mode over here? Because the most frequent occurring flower can be replaced with this missing value. So the what I'm saying, the missing value will be replaced with most frequent occurring element, right? So we can definitely say that most frequent element you can actually get it by using mode, okay, which is most frequently used, and this specifically works well with categorical variable. Okay, now let's take another example. Suppose I have a feature age. I have values like 25, 26 dash 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 32, 34, 38. Now in this particular case, what do you think, what may be a suitable thing? Suppose let's say that these are my ages of students. What do you think, what should I actually apply? Okay, what should I actually apply? Should I apply mean, median, or mode? Which do you think, based on this scenario, that is ages of students, we should definitely apply? Just tell me this answer. In this particular case, definitely I would suggest let's go with mean, because I know students age will basically range from one value to one value. Okay, it won't extend more than that specific value, right? So here a domain knowledge will also come into existence. If I say that this is probably the ages of all the population throughout the world, probably I'll not go with mean. Okay, so something like that, so this is a very good example, very good understanding with respect to various use cases that we can actually think. So till now, how is the session going on? Apart from the mistake of median that I have actually done, how is the class going on, guys? I know you are probably very much angry. You know, कितना भी अच्छा पढ़ा लो, कहीं कुछ गलती करते हैं तो पूरी दुनिया गाली देती है. That कहावत is there. I'm making my own कहावत nowadays. Okay, they will scold definitely. अरे क्या पढ़ा रहे हैं सर? But I hope you are able to understand, right? Yes, 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 yes. Great, great. चलो इस बात पे लाइक कर दो यार. 900 लोग हैं. You have to make the likes 1000, cross 1000. That is always my target, when I'm actually investing my 1 hour, right? Okay, I'll say this kind of sherry again and again, okay? But I want to see likes 1000. Come on, guys. You can do this. Yes. When I can do it, you can also do it, okay? So we'll have this kind of fun conversation for a little bit of time so that you can also digest what I'm actually explaining. Okay. Pushpa, like this, huh? That I think everybody has seen Pushpa movie. Uh, I'll also say, I'll never give up. Okay. Now, let's go and discuss about the next major topic, which is called as measure of dispersion. Now, in measure of dispersion, what all things we specifically discuss? We discuss about two main topics. One is variance, and the second one is something called as standard deviation. Okay. So these are the two topics that we are probably going to discuss. Okay. So let's go ahead and let's discuss about this. Now, first topic is basically with respect to variance. Now, how do we define variance? Variance is a concept of measure of dispersion. Okay. And probably for an interviewer also, this may be a confusing question they may ask candidates, and they may probably make them understand different things, and they may again confuse you. Okay. But when I say dispersion basically means spread. Okay. Please make sure that you remember this word. This basically means spread. Okay, spread. How well spread your data is. Okay, with the mean, obviously, see, let's say that I have two data sets. I have data set like 1, 1, 2, 2, 4. What is the mean? 4 plus 6, 8, 9, 10. 10 divided by 5 is 2. 10 divided by 5 is 2, right? Now let's consider that I have another distribution which looks like this. 2, 2, uh, 2, 2, 2. This is my next distribution. If I try to find out the average, then also it is 2, right? So for both this distribution, we are getting the same average or mean. I'm getting the same mean, right? So if I'm getting the same mean, then how do I identify that these two distributions are different? Because we need to think about it, right? How do we basically come up like with this is that how this two distribution is different? Okay, we really need to understand. Okay, and probably interviewer may say you and he may confuse you in dispersion. What is variance? He may definitely confuse you. So for that specific reason, if you really want to identify, okay, how two distribution are different, at that point of time we may use variance and standard deviation. Now let's go ahead and let's try to understand the formula with respect to variance and standard deviation. And here also I will probably talk about two different things. And here one very important interview question will come. One is population variance and one is about sample variance. So these two things, why I am teaching you with respect to population sample, it will all make sense. Okay. So usually population variance is given by something called as sigma square. Here you basically use as summation of I is equal to 1 to capital N x of I minus mu whole square divided by N. Okay. Sample variance is basically given by small s square summation of I is equal to 1 to small n x of I minus x bar. X bar basically means sample mean divided by n minus 1. Now many people will say, so why n minus 1, n minus 1? Yes, this is an interview question. I will talk about it. Okay, I will talk about it. Don't worry. Okay. So let's take one very good example probably, and we'll try to solve this specific problem. Okay. Let's consider that I have my x value as 1, 2, 2, 3, 4, 5. Okay. So this is my distribution over here. Okay. And probably over here, this is basically my data set. I'll just, guys, if you keep on, okay. Okay. No scoldings I'm getting. Okay. That basically means I'm teaching well. Okay. So first thing first, let's go and calculate. Now we'll go and calculate different things. Don't worry, guys. You'll also be getting assignments. So with respect to population, we'll go and calculate the mu. What is mu in this particular case? What is mu? Quickly, 5 plus 4 plus 3, 12, 14, 16, 17. 17 divided by 6 is nothing but 2.83. Okay. So here mu is basically 2.83, 2.83, 2.83, 2.83, 2.83. Okay. The next thing is that from this equation, I will try to calculate x minus mu, right? So what is x minus mu over here? Just do the calculation, and it is good that you do the calculation. So here I get minus 1.83, here I get minus 0.83, here I get plus 0.83, here also I get 1 point, sorry, it should not be 83, it should be, I'm extremely sorry, just a second. This is not 83. Oh no, this is 83, sorry. 0.83. This will basically become 0.17. This is plus. And over here, you will be able to see that this will become 1.17. And then for the 5, you have this and it will become 2.17. Is it accurate, guys? Yes. 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 I hope everybody has got this. Okay. Now the next step, you basically do the squaring. Now if you do the squaring, that is x minus mu whole square. You just have to do the square of this. So what is the square of this? 1, just a second, 1.83 square, 3.348. 3.34, 3.34. This is also 3.34, 3.3. Oh, sorry. 0.83 whole square. Then again, we have to go and compute. So I will write 0.83 whole square, 0.6889. So here you can see 0.6889. Then here also I can see 0.6889. And then for the remaining one, you can do the calculation. So here it will be 0.03, 1.37. And finally, you will be able to see 4.71. Okay. Why are we squaring? Because the formula says square, right? Right? Okay. Then what we do? We do the addition of this. Because summation of this is there, right? So once we do the addition, probably then we probably calculate it. If I do the addition, this is nothing but 10.84. Okay, 10.84 divided by 10.84 divided by 1 2 3 4 5 6. So what is 10.84 divided by 6? 1.81. Okay, now understand one thing. Okay, let's say if I have a data set which looks something like this, and if I have a data set which looks something like this, comparing this two data, where do you think the variance is more? This is my question to you. खुला चुनौती, बोल दो आंसर तुम. Which is basically having maximum variance? A simple question to you. Come on, quickly. Which will have the more variance? Variance, understand variance. Whenever your things comes into mind, it should be talking about spread, right? So over here in the second picture, definitely variance will be higher. Let's consider that. I'm just going to take this example. Here my variance is 1.81. Let's consider that this is 1.81. Okay, let's consider. Okay, and tomorrow if I probably get 5.45, can I say that it may belong to this particular distribution? Yes. So the variance will be definitely higher because the spread is quite high. Okay, spread is definitely high, right? Spread, when we say spread is basically high, that basically means the elements that is present in the central region is more. Okay, so always understand that specific thing. Clear everyone? Clear everyone? Yes or no? Whenever I talk about more variance, that basically means the data is more dispersed, right? Clear, guys? Clear? Everybody clear or not? Let me talk about this also to you so that you can understand. Oh, may show you some of the images to make you understand, but I hope you're getting it or not. Clear? Great. Right? Okay, just a second. Give me a second. I will just show you one image from Wikipedia. Okay. Everybody is able to see this image? Everybody is able to see this image? Everybody is able to see this image? Just give me a yes or no. Okay. Now let's forget about standard deviation for right now. Okay. I will just do like this. Okay. I hope everybody is able to see this. Okay. Now, in this particular image, let's see. In this particular image, what do you see over here? You can see over here standard deviation is 10, standard deviation is 50. Now, if you see standard deviation formula, it is nothing but root of variance. Okay, root of variance. Now, here you can see when the standard deviation is smaller, that basically means you're having a very huge curve. That basically means the data is not that much distributed. When you have a big standard deviation like 50, 60 and all, you can see your data is highly distributed, right? So this is very much important to understand. Why variance is more for dispersed data? Because over here you can see, right guys? Okay, when you probably calculate, I'll show you some of the problem statements over here, but just understand this graphically. Okay, later on I'll just show you one example where probably I will talk about it, and let's try to solve that particular example, and then we can definitely understand it. But some idea you basically got, right? Because obviously the variance needs to be spreaded high if the variance is high, right? The dispersion becomes high because you have more number of values inside it, right? So understand one thing. Now let's go ahead and let's try to see. Now I got my variance as 1.81. Okay, now my standard deviation is nothing but root of variance. Root of variance, that basically means it is nothing but root of 1.81. Okay, root of 1.81. Okay, so if I go and open my calculator, I'll just say root of 1.81, and there I'm actually getting is nothing but 1.345. Okay, so 1.345. Now see, what does standard deviation basically mean? What is the mean in this particular case? What is the mean? Mean is nothing but 2.83, right? Let's consider this one. The mean is 2.83. Now, from this mean, your data will be distributed because mean is basically specifying your measure of central tendency. It basically says that where the center is there for that specific distribution. Okay. So, where the center is actually present in that specific distribution. So, from here, if I go one step right, one standard deviation to the right, you have seen standard deviation formula. The next element that may probably fall between the one standard deviation will range between, let's consider that this is my first standard deviation to the right. Then it will basically have 2.83 plus 3.4. So this is nothing but 4.17. That basically means in this distribution, whatever elements are basically present between 2.83 to 4.17 will be falling within the first standard deviation. And if I consider the same thing towards the left, that basically is one standard deviation towards the left, then what I will do, I'll just subtract 1.34. So this will basically be 9,741. So it will basically become 1.49. Now here it basically says that any elements that falls between 1.49 to 2.83 will be falling in this region, that is one standard deviation to the left. Everybody clear? Similarly, we'll go with the second standard deviation, right? We'll go with the second standard deviation. Now, in this particular case, it will be 4.17, 1.34, 5, 5.51. Okay, so here you can see 5.51. Similarly, you go and calculate. Similarly, you go and calculate. Similarly, you go and now, your standard deviation is a very small number. Still, I'll say that this is a small number. And if I probably try to construct a graph, it will look something like this. The tip, right? This region that you probably will see, this is basically called as a bell curve. And based on the standard deviation and variance, you'll be able to decide two important things. With the help of variance, definitely you'll be able to understand how the data is spread. And with standard deviation, you'll be able to understand that between one standard deviation to the right and the left, what may be the range of data that may be falling. Okay. So standard deviation is nothing but it is the square root of variance. That basically means from the mean, right, how far an element can be. Let's consider that if I consider 5. Okay. Now for 5, if you try to calculate, it may fall somewhere here. So how you are going to represent 5? You will say that it falls in 1.5 standard deviation from the mean. From the mean. So this kind of definition you will be able to tell them. Okay. So that basically means from the mean how far a specific number is with respect to standard deviation. You're calculating, you're using a unit called as standard deviation for saying that. And variance specifically talk about spread. If the variance is high, the values, the data spread that is there is very, very high. Okay. I hope everybody is able to understand till here, guys. Yes. Everybody is following this. Yes. 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 Everyone. Yes. Just tell me if you are able to follow this. Whatever things we have actually discussed till now, are you able to follow it? Yeah. Perfect. Okay. Perfect. So great. You are able to understand. I hope everybody is able to see it and understand it. Okay. Now let's understand some amazing basic things which is called as percentile and quartiles. So here I am actually going to discuss about percentiles and quartiles. This is the first step to find outliers. How do we find an outlier? Okay, so probably we are going to discuss in this the first, and with the help of code also you can basically do. Okay, now with respect to percentiles, let's try to understand what is percentiles and how do you find out percentiles. Okay, now before understanding percentile you basically need to understand about percentage. Suppose if I have a distribution, I say 1 2 3 4 5. Now my question is that what is the percentage of numbers that are odd? Now this is my question to you guys. Okay, what is the percentage of numbers that are odd? Guys, don't worry about sample variance. I'll come back. Okay, I'll come back. Coming to sample variance. Okay, so I've defined the formula already over here. Sample variance is n minus 1. At last, I'll put up a question. I want to give you an assignment. Okay, so don't worry. I'll talk about that also. Okay, yes, sample variance I'll give you as an assignment. I want some kind of answers from you. Okay, and we'll discuss after we complete some topics. Okay, so don't worry. So over here, if I really want to find out the numbers, percentage of the numbers that are odd, okay, so how do you basically apply a formula over here? So I can basically say percentage is equal to number of numbers, number of numbers that are odd divided by total numbers. So if I really try to calculate how many numbers are odd, 1, 2, 3. So 3 divided by 5 is nothing but how much? 0.6, which is nothing but 60 percentage. Very simple. This is how we basically calculate percentage. Okay. Now, and I hope everybody knows this. Now let's understand a very, very important topic, which is called as percentile. Now, probably think you have heard about percentiles in a lot of things. Percentile, probably if you have given GATE exam, CAT exam, GMAT exam, right? SAT exam. Okay, one real life example I'll show it to you. That is related to my YouTube ranking also. If you can see my YouTube ranking, Social Blade. So here, if I show you one example, okay, here you can see that you can see education rank. Here, if you hover over here, it shows 96.1527 percentile. If I hover over here, it shows 94.98 percentile. Over here, if I hover, it shows 94.958 percentile. So we'll try to discuss about these percentiles right now. Okay, and it'll be amazing. You'll be able to understand in an amazing way. Okay. Now, first of all, we will give the definition. What is a percentile? So, a percentile is a value. A percentile is a value below which a certain percentage of observations lie. Okay, so this is the definition of percentile. It is basically saying it is a value. If I say, okay, this number is the 25 percentile, this basically says that 25 percentage of the entire distribution is less than that particular value. Okay, so percentile is a value below which a certain percentage of observation lie. Let me take a very good example and show it to you. Suppose I have a data set, and inside this data set I have elements like 2 comma 2, 3 comma 4 comma 5 comma 5, 6 comma 7 comma 8 comma 8, one more 8, 1 2 3 4 5, 9 9, 10, 11, 11, 12. Okay, so let's consider that this many number of elements that I actually have. Okay, now in this specific number of elements I want to find out what is the percentile. Let's consider this one. My question is, what is the percentile ranking of 10? So this is my question. What is the percentile ranking of 10? So 10 is a value over here, you can see. And I really want to find out what is the percentile value, what is the percentile ranking of 10. Okay. Okay. So how do we solve this problem? We solve this problem by using a simple formula. So I want to find out the percentile rank of 10, right? So my formula, let's consider this x is equal to 10. Okay, so here I'm specifically going to write x. Okay, so my formula will basically be number of values below x divided by small n, which is my sample, multiplied by 100. So if you try to calculate this number of values below x divided by n, what is n over here? What is the n size? N size is sample size. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 is basically my sample size. So here I am going to say number of values below x. So how many number of values? X is 10. How many number of values are below x? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this will basically become 16 divided by 20 multiplied by 100. In short, this will become 4 4s are 16, 4 5s are 1s are 20s are. Am I getting 80 percentile? Is everybody getting this much? Just let me know if you are able to find out this. Yes? So 80 percentile will basically be my answer for this. That basically means if I really want to find out what this 10 value percentile is, it is 80. Now understand what is the main meaning out of it. The main meaning is that 80 percentage, please listen to me very, very carefully. 80 percentage of the entire distribution is less than 10, right? 80 percentage of the entire distribution is less than 10. This is the real meaning that you can probably understand from it. Okay, now quickly try to find me what is the percentile ranking of 11. This will be an assignment to you. Please do it right now. I'll give you 2 minutes. What is the percentile ranking of 11? Okay, so this is the formula. What is the percentile ranking of 11, of value 11? Quickly, I'll give you time. Please do it. Hardly 2 minutes. What is the percentile ranking of 11? 85? Are you sure? So, how many elements are present below 11? I'll say 17 divided by 20 multiplied by 100. Ones are, fives are 85%. Congratulations, you have done well. Okay, congratulations. Huh? Good job. Like this. Good job. Okay, good job. Okay, now let's do something good. Like, let's do the reverse of this. So, from this particular distribution, what is the percentile, or I'll say, what value exists at percentile ranking of 25%? So, this is my question. Yes, we need to sort the numbers. It can have duplicates. Okay, guys, you have to make sure that 1,000 likes is there, otherwise I'll not come from tomorrow. Okay, how, if you don't like, then how I will get the motivation? Right now you are the Red Bull for me. It can give me wings. Okay, so what value exists at the percentile ranking of 25 percentage? Okay, so how do you calculate this? For this you use a very simple formula, and the formula is something like this: value is equal to percentile divided by 100 multiplied by n plus 1. Now see guys, I'm not going to derive the formula, why it is n plus 1, why it is n minus 1, why it is this. For sample variance, I'll discuss about why n minus 1. But understand, we really need to understand what things we are doing and how we are using it in some specific purpose. Okay. So percentile over here is 25 by 100 multiplied by 21. Okay. So what it is? So 25 multiplied by 21 divided by 100. So the answer is 5.25. Now understand this. This 5.25 is the index position. Index position. It is very much important to understand. This is not the value, the index position. Now I will go and find out which is 5.25. So this is my first element, first index, second index, third index, fourth index, fifth index, and 5.25 will be in between this. But right now I don't see any element find between this. So what we do is that we take fifth and sixth index, and then we do the average and we calculate the value. In this particular case, my answer will be 5. Okay, so 5 is the value for 25 percentile. Clear or no? Clear or no? You want white background? You want this background, guys? I think black was good, no? Black is nice, no? I like black. Otherwise, I'll also not be able to explain you properly then. Oh no. This is done. That was the point where I did a mess. Oh my god. Whatever I have written, it got wasted. Some guys, because of you, now it cannot be converted into white. I'm extremely sorry. Because of some people, this thing happened. Can't help now. Sorry. I cannot convert the text. Because of some people, this happened, guys. I'm extremely sorry. I can make things better, but I don't think so I can make it. Thanks to the guy who made me do this for no reasons, because I was teaching in a better way and he felt jealous of me. Oh, Control Z will work, huh? No, Control Z is also not working. Gone, guys. कर दिया उसने काम तमाम. क्या ही बोले. Okay, but don't worry, we have some more topics, we'll cover it. Okay, but very bad. I really want to say that this was the point where you messed up. Okay, it's not happening redo and Control Z and all. Okay, okay guys, so let's go ahead and let's try to complete the next thing. One question for you: try to find out what is 75 percentile. What is the value in 75 percentile? Quickly do it for me. Guys, now to decrease the brightness and all, I'll do it for tomorrow's class. Now let's continue. What is the 75 percentile? Quickly tell me, guys. See, if I'm using black, right, it is getting converted now. This is becoming black. It had to become white. This is the problem. Run. Okay. Okay, what is 75 percentile, guys? What is the 75 percentile value? Okay, many people are saying it. So if I use 75 divided by 100 multiplied by 21, this is nothing but, I'll use my calculator now. So I'm going to basically say 75 divided by 100 multiplied by 21. So it is 15.75. Understand, 15.75 is the index position. Now go and count which is 15.75 from the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15.75 is the sum of these two numbers. So my answer is 9. Okay. So here I'm basically getting 9 as my answer. Okay. 15.75 is the index position. So here I'm basically getting the 9 answer. Okay. Everybody clear? Can I get a quick yes if you are clear, so that we will continue the session? Guys, now I can't do with respect to the font and all. You all messed it up, so I'm not responsible for that because it is not getting reverted. Okay. Now let's go and discuss about a new topic, which is called as 5-number summary. Let's try once more, okay? Background was black. No, it is not changing, guys. Extremely sorry now. It's not changing. Can't help. Okay. Now let's go ahead and discuss about 5-number summary. In 5-number summary, we need to discuss about something called as, some topics that we probably need to discuss is like 5 main topics as the number says. First one is something called as minimum. The second topic that we should discuss about is something called as first quartile, which is also denoted by Q1. The third topic that we must discuss about is something called as median. The fourth topic that we should discuss about third quartile, which is also read as Q3. And the fifth topic we basically discuss about maximum. And with the help of this, we will be using these values to basically remove the outliers. Okay. So let's take one example and let's see that by the help of 5-number summary, how do we remove an outlier? Okay. So removing an outlier, a very important thing which is also called as IQR. So here we are going to discuss about removing the outliers. Okay. Now removing the outliers, let's consider that I have one data set which is like this: 1, 2, 2, 3, 3, 4, 5, 5, 5, 6, 6, 6, 6, 7, 8, 8, 9, 27. Now from this distribution, guys, what do you think is which is the outlier over here? Anand, please focus on the lessons. It's okay. Okay. So what do you think over here? Okay. What do you think over here is the outlier? What do you think? Which is the outlier? What do you think which is the outlier? So obviously you'll be saying that 27 is the outlier. Always understand, guys, whenever we need to remove an outlier, we really need to define a lower fence. Let's consider that I'm going to define a lower fence, and then I'm going to define a higher fence. The values that you have over here will be between lower fence to higher fence. That basically means after a greater number, all the numbers above that number will be an outlier. After a smaller number, all the number below that particular number, below this lower fence, will be actually treated as an outlier. It should also have higher, it should also have lower. If I consider that I had one element which is called as minus 50, is minus 50 an outlier for this distribution? Is minus 50 outlier for this distribution? Yes, the answer is definitely yes, right? If you have minus 50 over here, that is probably in the lower fence side, below the lower fence side, and it can be treated as an outlier. So in order to define the lower fence, what we do, we write a very simple formula. And the formula looks something like this. So here you can define lower fence is equal to Q1 minus 1.5 multiplied by IQR. Okay, I'll talk about what is IQR. And upper fence is basically defined as Q3 plus 1.5 multiplied by IQR. Okay, so these two things are basically there. Now, what exactly is IQR? You really need to understand about IQR. What exactly is IQR? IQR is nothing but it is called as interquartile range. Interquartile range, okay, is basically IQR, and it is given by the formula Q3 minus Q1. Q3 is nothing but 75 percentile and Q1 is nothing but 25 percentile. Okay, now quickly check this distribution and try to find out the 25 percentile. So what exactly is 25 percentile? What exactly is 75 percentile? You do it in front of me. Q1 is 25 percentile. Interquartile range. Now quickly calculate it for me and tell me the answer. Tell me the answer. Till then, for those people who did not hit like, please hit like. Yes, 1.5 is fixed, guys. Tell me quickly what is the 25 percentile and what is the 75 percentile. We did it right now. Very simple, no? 25 and 75 percentile. How do we calculate 25 percentile? It's simple formula: 25 multiplied by 100 multiplied by small n. Small n is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. 19 plus 1, right? So this is nothing but 25 by 100 multiplied by 20, which is nothing but 5. This 5 is nothing but index position. So what is the fifth element index position? 1, 2, 3, 4, 5. Is everybody getting 25 percentile is nothing but 3? Is everybody getting 25 percentile or Q1 is equal to 3? Yes. So similarly, if you try to find out Q3, you will be able to get that it is 7. Q3 is 7. Okay. You will get the 15th index for Q3. So you are basically going to get 7. Now, if I go and compute the interquartile range, what is interquartile range? 7 minus 3, which is nothing but 4. Everybody is getting it? Q3 is 7, guys. You get the 15th index position. Till here, everybody is able to understand? Yes, yes, yes. That is the formula, guys. Formula of computing values from this percentile. Okay. Akash Singh, that is the formula. If you have not attended this, you will not be able to understand the further things. Okay. Now you have calculated the IQR. So what all things we have calculated? The IQR, Q3, Q1, everything is being computed. Now let's go ahead and compute the lower fence. Now the lower fence basically say Q1 minus 1.5 multiplied by IQR, right? This is what lower fence formula is. So what is Q1? Q1 basically is nothing but, what is Q1 in this particular case? I have computed it, it is 3. You can see over here, Q1 is 3, Q3 is 7. So I'm going to write 3 minus 1.5. What is IQR? 4. So 3 minus 6, which is nothing but minus 3. So the lower fence value is minus 3. Now let's go and compute about the higher fence. Higher fence basically say Q3 plus 1.5 multiplied by IQR. Now if I go and compute this, what is Q3? Q3 is nothing but 3 plus 1.5 multiplied by 4. So this is nothing but 3 plus 6, which is nothing but 9. So what is my higher fence over here, guys? Quickly. It is nothing but, sorry, 1.4. Oh, one mistake that I have done. Sorry. 1.4 multiplied by 1.4 multiplied by this. Oh, sorry. Q3 is 7. Just a second. This is right. Q3 is 7. 7 plus 6 is equal to 13. Okay. So my lower fence to higher fence range is between minus 3 to plus 13. Everybody got this? Everybody got this? Now tell me which is the outlier from here. Minus 3 to plus 13. Anything that is greater than 13 is considered as an outlier. Anything lesser than minus 3 is considered as an outlier. So which number should we remove? Guys, 19 plus 1 is because of this formula, right? N plus 1. Please revise those, okay? So which number we should remove? We should remove 27. Why? 27 is greater than 13, which is from the higher fence. Okay. Now let me write the distributions once again for all of you. Okay. Let me write the distribution after removing the 13. So remaining data. So the remaining data, what I have, 1, 2, 2, 3, 3, 4, 5, 5, 5, 6, 6, 6, 6, 7, 8, 8, 9, 27. But I told you we are removing 27, right? So 27 is removed because it is an outlier. Now you know what is the minimum value out of all these numbers? Quickly tell me, guys. Minimum value is 1. Okay. What is Q1? My first quartile we have computed over here. Q1 is nothing but 3. Okay, Q1 is nothing but 3. Median you calculate and tell me quickly. Then you have Q3. Q3 is 7. Okay, and the maximum number after removing the outlier is nothing but 9. So here you are getting your 5 number summary. So here you are basically getting a 5 number summary. Now quickly compute median and tell me what is median. What is median, guys? Sir, how you calculate ki Q1? Q1 is basically 25 percentile. If you have joined late, please make sure that you watch the video. Okay. So median, obviously over here, how much median is? Median is nothing but 5. Now let's draw a plot which is called as box plot. By this specific data, you can definitely draw a box plot. Now, how does a box plot basically get drawn? So you will be having x-axis, and let's consider that in this particular x-axis you have values like -2, 0, 2, 4, 6, 8, 10. Okay, so this is your x-axis. Now just to go and find out where is minimum element. Minimum element will probably fall over here, that is in 1. This is your minimum element, right? Q1 will basically fall at 3. So this will be your 3. Median is basically 5. So this is basically your 5. Okay. Okay. Q3 is nothing but 7. So this is your 7. And max is nothing but 9. So this is your 9. Now all you have to do is that join these lines and join these lines. Okay. So this exactly is your box plot. If I had kept 27 as an element, I would have to extend this line this much big and probably put 27 somewhere here, and this used to be one dot over here. Have you seen this kind of plot? This value is nothing but minimum. This is my Q1, this is my median, this is my Q3, and this is my max. Clear? Clear, everybody? And this technique of removing an outlier, we basically say with respect to lower fence and higher fence. And we also use something called as IQR. Right? So how was the explanation overall, guys? How was the explanation? Did you like it or did you not like it? Yeah? Yes? So can I get 1000 likes completed till now? 1000 likes, 1000 likes finally got completed. So guys, this today I have probably covered this many topics. Tomorrow we are still going to go into more advanced section, and probably I hope everybody's liking it, whatever I'm actually teaching. Okay. And this is how you basically learn. The first application that I shown you here, this is also used extensively in data visualization. So you really need to know all these things. I've drawn it in front of you. I can also do this with code. I have to just install a library. In matplotlib you have a library where you can probably do all these things. Okay. Now let's come back to understand about variance. Summation of I is equal to 1 to n x of I minus x bar whole square divided by n minus 1. This n minus 1, why we do it, it is also called as Basel correction. We also say it as degree of freedom. Okay, degree of freedom. And I have probably made this video in my stats playlist, why sample variance is divided by n minus 1. You can go and search for that. Because of time constraint, again same thing, I will not explain you, but over here you can definitely understand these things now. Okay, so overall, this was the topics that I want to cover. Tomorrow we'll basically start with distributions. We'll finish up normal distribution. We'll finish up log normal distribution, standard normal distributions. We'll discuss multiple things. Then we'll move towards confidence interval. Then we'll move towards p-value, hypothesis testing, z-test, t-test, chi-square test, ANOVA test, this test, that test, everything. We'll try to finish it up. So I think our speed is very much good. Now tell me, one interview question may come that what is the application of box plot? Someone tell me. Box plots can be used to determine outliers, because as I told you that if I was giving 27 over here, my element would have come over here, right? So box plot actually gives you a visualization way to basically see where an outlier is actually present. If someone asks you how do you create or how do you determine an outlier, you can explain this entire concepts whatever I have explained with respect to percentiles, right? So all these things are actually there. Okay, so if you like the session, make sure that you share with all your friends, guys. Now one final thing I want to talk about is about our one neuron platform, right? So one neuron, if you remember, guys, please go ahead and take this up. These courses are absolutely good. I'm telling you, we have put up a lot of efforts in creating this course. Okay, so with respect to one neuron, you will basically be getting 100 plus courses. Right now every month we are recording 100 plus courses. And remember, guys, right now it is for lifetime subscription. That basically means you just have to pay 6,000 plus GST to take up all these courses. Name the courses that you want. Suppose you want to go with blockchain. Blockchain is basically there. Okay, so blockchain is there, merge stack is there, data science is there. See, guys, if I talk about ML masters, machine learning masters, I'll show you today. How many videos do you think we have in machine learning masters? In machine learning masters, if you go and check out, we have somewhere around more than 100 to 200 videos. Okay, so you will be able to see all those things over here, right? That is what we are trying to do. We are trying to put everything, we are trying to put all the course content over here, and you will be able to see it. Any courses that you probably don't have, you can raise your demand. Okay, and this kind of live sessions, which I'm probably taking it as community sessions, this will also be available for you all when we are doing communities part. For live sessions also in iNeuron, you will be having for full day, which we are probably planning for next month. You can request your course, you can you can request a new module, you can everything. And guys, remember, it is for lifetime. Right now it is for lifetime. Okay, probably after a couple of months you won't see these options. Over here we are planning to add another 100 courses. After that you will not be able to see this, that you will be able to get this lifetime subscription. So that is the reason all the information is given in the description. You can also use Krish 10 to get 10% discount. Okay, so everything is there. See, we have even added aptitude. You name the course, I will search for it. You name the course, I will search for it. Suppose you want AI ops, AI ops is there. If you want deep learning, that is also there, right? Deep learning, everything is there. If you want stats is there. You want C++, it is there. You want DSA with Python, right? DSA with Python, that is there. You want merge stack, that is there. So it is an effort from our side to give you the best thing with respect to the affordable courses. So please make sure that share with all your friends, and it will definitely be helpful to spread this kind of knowledge with everyone so that they can request. anything. Any new course that you don't find over here will get uploaded. You can also search for blockchain, you can search for Java. See, blockchain is also there. You can search for AI ops is also there, right? Linear algebra is included inside your data science and other courses, right? So I hope you like this. Please make sure that you utilize this opportunity. Tell all your friends. C++ is also there. Everything is there, guys. Till now, GCP, AWS, that is also there. You can see AWS, GCP, everything is there, right? So thank you, everyone. Yes, net banking is there, so you can use it. Thank you, guys. So we'll continue the session tomorrow at 7 p.m. And I hope you like this video. And yes, I'll see you all in the next session. Please make sure that you subscribe, hit like before going, and we can have a lot of fun in tomorrow's session. Tomorrow's session, we are going to move towards advanced. Okay.